So for this, the first thing I'm going to write is my definition of a quadrilateral. It is a four-sided polygon. And this is what I call one if I can't make it any more specific. Then there's three specific types of quadrilaterals. There's parallelograms, there's kites, and there's trapezoids. Parallelograms have two sets of parallel sides. So if I'm looking at these on a coordinate plane, I would want to look for two sets of the same slope. And then I'm going to mark up my picture to show parallel sides. Remember, I do that with triangle or with arrows. Then I have kites. These have two sets of adjacent equal sides. So what that means is the two sides next to each other are congruent. So the top two would be congruent, and then the bottom two would be congruent to each other. Then I have trapezoids, which have one set of parallel sides. Then, from parallelograms, I have two specific kinds of special parallelograms. You can either be a rhombus or a rectangle, or you can be a parallelogram in general. There's just more specific parallelograms. So for the rhombus, it's going to also still be a parallelogram, so it's going to still have my two sets of parallel sides. But in addition to that, it has four equal sides. So if I'm looking for this one on a coordinate plane, I'm going to want to look for the same distance and the same slope. So this one, all four sides are going to be congruent. Then I have rectangles, which they're still parallelograms, so they still have two sets of parallel sides, but they also have four right angles. If I'm proving this on a coordinate plane, I want them to have opposite reciprocal slopes, so where the angles meet, and then the same slopes for parallel sides. So I'm going to draw right angles on my rectangle as well. So the final parallelogram is a square, and this is special because it's both a rhombus and a rectangle. So it's going to have 4 equal sides and 4 right angles. And it's also still a parallelogram. So if I'm looking at a picture on a coordinate plane, I want to have the same distance. I want to have opposite reciprocal slopes for sides that touch, and I want to have same slopes for opposite sides. The last special kind of quadrilateral I have is an isosceles trapezoid, which is a trapezoid. This one has non-parallel sides are the same length and cross at the same angles. And then when I wrote down the distance formula earlier, I forgot that the last parenthesis needs to be squared. So make sure you have a 2 up there too as well. So on the back side, we're going to go ahead and do some graphing to see what certain shapes are. So our first one is going to have A at 2, 1, B at 5, 1, C at 5, 3, and D at 2, 3. Okay, so I want to go ahead and plot my points. So I have 2, 1, so I go right 2, up 1. I have 5, 1, so I go right 5, up 1. 5, 3, I go right 5, up 3. And 2, 3, I go right 2, up 3. Okay. Then I want to go ahead and connect my points. Okay, does anyone have an idea of what this shape is? This one is a rectangle. I have my 2 parallel sides, and I have 90-degree angles, which I can see on this one because of the nice grid lines. Okay, my next one, I'm going to have F is -2, -1. I have G is 0, 2. H is 4, 2. And I is 2, -1. And then I want to go plot my points. I have -2, -1. I have 0, 2. I have 4, 2. I have 2, -1. Okay, so I want to connect my points. So already I can tell I don't have right angles. This isn't going to be a rectangle or a square. I need to decide if I have parallel lines. I know that the straight across lines are going to be parallel, but I need to see if FG and IH are parallel. So what I can do is I can use my slope. So I'm going to draw a slope triangle on here. I'm going up 3 over 2. So remember, it's rise over run. Then I want to find my slope for IH. I'm going up 3 over 2. So do I have the same slope between those? So I know this is a parallelogram and not a trapezoid. I need to check to see if this is a rhombus. So I need to check to see if my sides are the same length. So I know GH is 3, because I can count those squares. And, no, 4. I can't count. And then FI is 4. So I want to see if FG is also 4. I can use the distance formula, but since I already have a triangle, I can use the Pythagorean theorem as well. So I am going to have 2 squared plus 3 squared equals C squared. Two squared is 4. 3 is 9. Okay. 4 plus 9 is 13. Then I would go and take the square root of both sides. So if I go to, maybe not, the internet is not working. I'll pull up Desmos on my phone. So I can go to Desmos, and I can do the square root of 13, which gives me 3.6. Is that the same as 4? 3.6. No. So this is not a rhombus. It's just a parallelogram. For my next one, I'm going to have J is at -2, 2. K is at 3, 1. L is at 2, 0. And M is at -1, -1. and graph this. So I have negative 2, 2, 3, 1. No, wait, I don't want 3, 1. My bad. I wanted 1, 3. Two, 0. And negative 1, negative 1. So then I want to connect. So this one looks like it might be a square. I need to check for sure. I first need to make sure I have parallel sides. So if I'm going from M to J, I'm going up 3, left 1. Which is the same thing as negative 3. I want to check with the side across from it, which is the LK. So this one is also going up 3, left 1. Then I want to check to make sure JK and ML are parallel. Those two work, by the way. Because they were the same number. So next I'm checking JK. I'm going up 1 over 3. And then I want to do the same thing for ML. So I go up 1, and this one is over 3. Okay, so these two are parallel. So that makes this a parallelogram. The first part of being a square is true. Now I need to make sure I have opposite reciprocal slopes. So every time a pink and a blue line met, I need to make sure they have opposite fractions and opposite signs. Is 3 over negative 1 opposite signs of 1/3? And then are the fractions or the numbers flipped? Okay. So I know that those are perpendicular. So I will write that. Remember, this upside down T means perpendicular. Now I need to check to see if all of these sides are the same length. All of them have triangles with 1 and 3. So all of them, let's do it this way. Kind of look some sort of like this. It might be mirrored, it might be upside down, but all of them kind of look like that. So all of them are going to have this final side. If I go do this blue one and this blue one, it's going to give me the same C value. And if I do the pink one and the pink one. So I'm just going to solve. I don't even need to solve because they're all going to be the same. So all of my sides are the same length. So this one is a square. Okay. My last one is P is -3, 0. Q is 0, 4. R is 3, 0. And S is 0, -4. Okay, then I want to go ahead and graph. Okay, so now that I have this, I want to find my slopes and see if they're opposite slopes and see if they're parallel. I am going to start with PQ. So this one I am going up 4 over 3. Then I want to do the same thing for SR. So this one is going up 4 over 3. Are these two lines parallel? Yep, they have the same slope. Next, I'm going to do QR. So this one is going down 4 and over 3. So this is -4/3. Then I want to do the same thing for PS. This one is going down 4, right 3. Okay, so any ideas on what this one is? These two are parallel. I heard what? So I have two sets of parallel sides. Is this a rectangle? This looks like a rectangle? Okay. Is it a square then? It's not a kite. It's actually, because it's a parallelogram, it has the parallel sides. That moves it over on that side. Is it a parallelogram or a rhombus? If I went and found all of my side lengths, all of them have triangles with 3 and 4. So that missing side is going to be the same length for all of them. So this one is a rhombus.